The topic that we'll be covering in this video is the margin of error. This is a topic that we've been building up to over the last few videos. In this video, we won't get into too much detail about how the margin of error is used. The purpose of this video is for you to understand the idea of the margin of error and for you to get an idea of what it means and for us to go over a few examples. So this video is really just an introduction to the concept of the margin of error. And we'll be continuing to discuss this concept as we go forward into future topics. So let's get into it. The margin of error, or a margin of error, is an amount of accuracy with a certain probability. I like to start off with the target analogy because I think that gets the concept across pretty well. So imagine you're shooting a dart at a target, and based on your skill level, you have a 0.70 probability of making it inside this ring right here. You have a 0.50 probability of making it inside this second ring right here, and you have a 0.20 probability of making it inside this inner ring right here. If that's the case, then you would say that this first ring is a 70% margin of error because it's the amount of accuracy that has a 70% chance of happening. You would say that this second ring is the 50% margin of error because it's the amount of accuracy that has a 50% chance of happening in this situation. And you would say that this third ring on the inside is the 20% margin of error because it's the amount of accuracy that has a 20% chance of happening in this situation. Like I said, a margin of error is just an amount of accuracy that has a certain probability of being reached or being achieved. So now let's move on. So when a random sample is selected, there's a different margin of error for every percentage between 0 and 100. There's actually no margin of error for 0 and 100, but there's a margin of error for every percentage in between. For example, when a random sample is selected, there's a 90% margin of error, a 91% margin of error, and even a 91.3% margin of error. Don't worry about why there's no margin of error for 0 and 100 right now, because right now I just want you to understand that there's a different margin of error for everything between 0 and 100, but you don't have to understand why that's the case yet. So just take my word for it. And here's a few examples of margins of error. So there's the 20% margin of error, the 80% margin of error, and the 95% margin of error. Those are just three examples that I decided to write out. And when a random sample is selected, each margin of error has its own probability. Just like we saw on the target, each margin of error has a certain probability of being reached. So here's a few examples. The 20% margin of error is the amount of accuracy that has a 0.20 probability. In my target, it was the innermost circle. The 50% margin of error is the amount of accuracy with a 50%, with a 0.50 probability. In my target, it was the second circle. And the 95% margin of error is the amount of accuracy that has a 0.95 probability of being reached. And in my target that I showed earlier, I don't think I had 0.95 listed, but I could have included a ring for 0.95 if I wanted to. It would be almost at the outside of the circle. So let's move ahead. So now I want to go over an imaginary situation just to help you get the concept down a little bit more fully. So imagine that I take a random sample of a city. It could be any city. And I do a survey and I record the age of each of my participants and I calculate the mean age of my sample. I add their answers and I divide. And let's say I also calculate the 20%, 50%, and 95% margins of error using the margin of error formula. Don't worry what the formula is yet because we'll be getting there later. We're not going to be doing any calculations just yet. And imagine I get these answers. The 20% margin of error comes out to 1, the 50% margin of error comes out to 3, and the 95% margin of error comes out to 4. Now, what are these numbers telling us? Well, the 95% margin of error was 4, and that's telling us that when I take my random sample, I have a 0.95 probability of getting a sample mean within 4 of the population mean. In other words, I have a 0.95 probability of getting a sample mean somewhere between 4 below and 4 above the mean age of the city, which is something I don't know. It's an unknown number. The 0.50 probability, I'm sorry, the 50% margin of error came out to 3, and that's telling me that when I take my random sample, I have a 0.50 probability, or a 50% chance, of getting a sample mean somewhere within 3 of the population mean. In other words, I have a 0.50 probability of getting a sample mean somewhere between 3 below and 3 above the mean of the city. And the and I said that we're imagining that the 20% margin of error came out to 1. That was on the last slide. And that's telling us that when I take my random sample, I have a 0.20 probability, or a 20% chance, of getting a sample mean somewhere within 1 of the population mean, somewhere between 1 below and 1 above. So let's look at what I just said in a diagram, just so you can see it visually. So here we have the population that I'm sampling from. I'm taking my random sample, and I'm calculating the mean age of my sample. I'm calculating the mean age of my participants, and I said we're imagining that the 20% um, margin of error came out to 1, the 50% margin of error came out to 3, and the 95% margin of error came out to 4. So, like I said, that's telling us that I have a 0.20 probability of getting a sample mean somewhere between 1 below and 1 above the mean of the city, somewhere in this range. I have a 0.50 probability of getting a sample mean somewhere between 3 below and 3 above, and ending up somewhere in this range. And I have a 0.95 probability of getting a sample mean somewhere between 4 below and 4 above the mean of the city. So basically, I have a 0.20 probability of getting a sample mean somewhere in this range, a 0.50 probability of getting a sample mean somewhere in this range, and a 0.95 probability of getting a sample mean somewhere in this range. That's what these 3 margins of error are telling us. So in the examples that we'll cover in our videos, the sampling distribution has to be normal or close to normal to calculate a margin of error. And in some of the last few topics we've covered, we've had a checklist in which we had to determine whether the sampling distribution was normal or at least close to it. And if the checklist didn't check off, the problem couldn't be solved. And when we get into calculating the margin of error, that checklist is going to show up again. We're going to have to go through a checklist to see if the sampling distribution is normal or close to it. And if it's not, then we can't calculate the margin of error. And the reason why the sampling distribution has to be at least close to normal is because we're actually going to be using the shape of the normal distribution to calculate the margin of error. And the z-table, which is based on the normal distribution, will come back into play when we calculate this value, the margin of error. So let's look at a situation in which a sampling distribution is close to normal. Just an imaginary situation. So here we have a population. We have a random sample of 30 or more. It's just something that's 30 or larger. And the mean of this sample is being calculated with the data that was collected. And here we have the sampling distribution, which is the means of all of the possible samples that could have been selected. And one of them is the actual sample. So once again, imagine that there's a bunch of boxes under here, and each box is a different possible sample. Just imagine the stick figures inside of the boxes again, like how I used to show you. And here's the population mean at the center. And now I want us to think about this middle 20% area right here. And I want us to try to think, what's the probability that this sample mean will end up somewhere in this area right here between these 2 points? And you might have guessed that the probability of getting a sample mean in the middle 20% of the sampling distribution is 20%, or 0.20 when you write it as a decimal. So 20% of the possible samples are in here, 20% of the boxes, and there is a 0.20 probability that the selected sample will be one of these possible samples in this middle area right here. And now let's look down here at the bottom of the graph. So here we have a bar and another bar, and each one goes from the population mean out to one of these boundaries, right? Well, this goes from the population mean to this lower end. This goes from the population mean up to this upper end right here. And this bar right here is called the 20% margin of error. So we have the middle 20%. There's a 0.20 probability that the sample will come from here, and half of the distance covered by this middle 20% is the 20% margin of error. So you can see that these are the same distance, right? Because the curve is symmetrical. Well, this side is the mirror image of this side, which means that these two bars are the same distance. So this is the 20% margin of error, and this is also the 20% margin of error. So you can think of the margin of error as being like the radius of a circle. It's half of the distance covered by this middle area that's been marked off. And since we're focusing on the middle 20%, this is the 20% margin of error, and this is also the 20% margin of error. And in this situation, this distance right here is the amount of accuracy that has a 20% chance of happening, right? The distance from the population mean out to here, and the distance from the population mean out to here, that distance is the amount of accuracy that has a 20% chance of happening, right? Because I said that you have a 20% chance. Well, I said in this situation, there's a 20% chance that the sample will make it into this area between these boundaries. Let's look at a couple more examples. So in this situation, there is a 50% chance or a 0.50 probability that the sample mean will fall between these two boundaries and end up somewhere in the middle 50%. And these two bars are the 50% margin of error. That's the 50% margin of error, and this is also the 50% margin of error. There is a 0.95 probability of the sample mean ending up somewhere between this boundary and this boundary, and this is the 95% margin of error, and this is also the 95% margin of error. So we have the amount of accuracy with a 20% chance of happening, the amount of accuracy with a 50% chance of happening, and the amount of accuracy with a 95% chance of happening. And before we can get into how a margin of error is calculated, we have to cover a couple more terms. So the confidence level is just the percentage that goes along with the margin of error. So if you're calculating the 70% margin of error, the confidence level is set to 70%. Or if you're calculating the 80% margin of error, the confidence level is set to 80%. So with just the percentage that goes along with the margin of error. And the confidence coefficient is the value that determines the confidence level. And you actually look up the confidence coefficient in a table when you calculate the margin of error. You don't calculate the confidence coefficient. You look it up from a table and you plug it into a formula to get the margin of error. And I'll just show you a few examples that I got from the table. So the confidence coefficient for the 70% margin of error is 1.04. And it's actually a z-score. And it's actually the z-score at the upper end of the middle 70% area. So if you want to get the 70% margin of error, what you do is you take this z-score, you plug it into a formula, and you get the 70% margin of error, which is the distance from here to here, and the distance from here to here. Now, if you want the 80% margin of error, your confidence coefficient will be 1.28. Once again, the confidence coefficient is just the z-score up at this upper end right here. So you plug this into a formula, and you get the 80% margin of error. And that's going to be the distance from here to here, and from here to here. And if you want the 95% margin of error, you take this confidence coefficient at this upper boundary, you plug it into a formula, and you get the 95% margin of error. So if you want to calculate a certain margin of error, like 70%, 80%, or 95%, what you do is you just look up the correct confidence coefficient from the table. It's a table that I'll be sharing with you. You plug it into a formula, and you get the margin of error for your desired percentage or your confidence level.